Let us draw a triangle ABC in which the sides AB, BC and CA are of the lengths C units, A units and B units respectively. And let's drop a perpendicular from C onto AB which intersects AB at a point D, and the length of this CD is H units, and this is called height with respect to the side AB of the triangle. Let the length DB be of X units, then AD will be of C minus X units as AB was of C units. So now this triangle has got split into two right angle triangles, and hence we can apply Pythagoras theorem to each of these. So in triangle CAD we can write A square is equal to B square minus C minus X whole square, as B is the hypotenuse in this triangle. And similarly in triangle CBD, since the hypotenuse, the longest side is CB, we can write here A square is equal to A square minus X square. So let this be the first equation and this be the second. Now on equating on these two equations, we get B square minus C minus X whole square is equal to A square minus X square. Now let's expand C minus X whole square. So we get C square plus X square minus 2CX, and rest of the things are the same. Now in this step we will open the bracket, and since we have minus outside, so all signs would get reversed. So we have minus C square minus X square plus 2CX is equal to A square minus X square,
and we will eliminate the identical terms on the either side.
So finally we are left with 2CX is equal to A square minus B square plus C square. So finally we got the value of X as A square minus B square plus C square by 2C. Now we will substitute this value of X in the second equation, which is X square is equal to A square minus X square, and we'll get the value of H in terms of A, B and C. So substituting X is equal to A square minus B square plus C square by 2C in equation 2, we get A square is equal to A square minus A square minus B square plus C square by 2C whole square. We can further express this using the formula x square minus y square, which is equal to x plus y into x minus y. So here we can write h square is equal to a plus a square minus b square plus c square by 2c into a minus a square minus b square plus c square by 2c. So now we can take 2c as the denominator, so we get 2ac plus a square minus b square plus c square by 2c, the first bracket, and in the second bracket we'll get 2ac, and since we have minus outside it becomes minus a square minus of minus b square, that is plus b square, minus of plus c square, which is minus c square by 2c. Now let's arrange these terms. A square plus c square plus 2ac minus b square by 2c. Let's arrange in the second bracket also. So in the second bracket we can write as b square minus a square minus of a square. So minus I have taken as common, so I am left with plus c square minus 2ac 2c. So this can be written as a plus c whole square minus b square by 2c, and here we can write b square minus of a minus c whole square by 2c. So now again, using the formula x square minus y square is equal to x plus y into x minus y, we can express the results which we have obtained, that is a plus c whole square minus b square, as a plus c plus b into a plus c minus b whole by 2c into the expression in the second bracket, which is b square minus of a minus c whole square. So we can write it as b plus a minus c and b minus of a minus c, which becomes b minus a plus c by 2c. So now let us take that the semi-perimeter of the triangle BS. So we can write a plus b plus c by 2 is equal to s. So here we can write a plus b plus c as 2s, So from this equation we can write the sum of any two sides, that is equal to 2s minus the third side. So a plus c can be written as 2s minus b, and a plus b can be written as 2s minus the third side, which is c. And if I take b and c together, then I can write b plus c is equal to 2s minus a. So we are going to substitute these values in the above equation, but before that we are going to arrange the terms of bait in each bracket. In the first bracket, since all the terms are positive, we won't mind, but in the rest three we will keep the negative term as the third term in each bracket. So we are going to now replace these values with the values which we have written alongside. So we get 2s times 2s minus b times 2s minus c times 2s minus a by 2c whole square. So this is nothing but 2s twice s minus b into twice s minus c into twice s minus a by 2c whole square. So in the numerator we find that 2 is being multiplied 4 times, so I can write 2 to the power 4 into s minus b into s minus c into s minus a by 2c whole square. So on further solving it, we get s square is equal to the power 4 times s minus a times s minus b times s minus c by 2c whole square. So we get h is equal to root over this whole thing, that is to the power 4 times s into s minus b into s minus a into s minus c by 2c whole square. So root over to the power 4 is 2 square, and root over 2c whole square is equal to 2c. So they come out of the root, and under the root we have s times s minus c times s minus b times s minus c. So this gives 2 by c root over s times s minus a times s minus b times s minus c. So this is what the value of h is in terms of a, b, c and the semi-perimeter s. We know that area of any triangle is equal to half times the product of its base and corresponding height, whereas base can be any side and the corresponding height is the perpendicular drawn to it from the opposite vertex. So in the given figure, triangle ABC, we see that if I take AB as base, the corresponding height is equal to CD. So the area of the triangle ABC can be written as half into C into H. But now I can replace H by the value we have got, that is
2 by C
root over S times S minus C times S minus B times S minus C. So C gets cancelled off, and 2 in the numerator and 2 in the denominator gets cancelled off, and finally we are left with root over S times S minus A times S minus B times S minus C. So this is the formula of the area of a triangle whose three sides are given, and this formula is called as Heron's formula. I hope I could make you understand, and thank you for watching this video.